Hi everyone, Miss Geppetta here, and today I'm excited to tell you about one of my favorite topics in pre-calc, and that is parent functions. Before I tell you what the parent functions are, I need to tell you the definition of a parent function. Parent functions are the very most basic type of function. You should think of it like every other function is based off of a parent function. Once you know the parent functions, you can understand a whole slew of other functions. The parent functions that we're going to look at have something called a focal point, and the focal point is always at the origin. When we look at the graphs of these, we'll know a little bit better what the word focal point means, but for now, just think about it as a point of reference, something to look for when you see a graph. And finally, the parent functions are useful because they help us to graph other functions. Once we learn about transformations, we'll use our knowledge of transformations and parent functions. We'll put these pieces of knowledge together and we'll be able to graph a ton of new functions. So let's get started. The first type of parent function that we'll study is probably the easiest since you're already familiar with it, and it's a linear function. The equation of the parent function is y equals x. So this is just a really easy version of a line. It's a line where the slope is 1, and b, the y-intercept, is 0. And so here, you'll notice that we cross both axes at the origin. The x-intercept is 0, 0. The y-intercept is also 0, 0. We'll use this as our focal point. And another important thing that you'll be expected to know about parent functions is the domain and range. From what we know about domains, the function y equals x, there are no problems. There's no square roots. We're not dividing by anything. So the domain is all real numbers. And the range is also all real numbers because if you give me an output, say 2000, I'll tell you what value for x you need to plug in order to get 2000. You just plug in 2000. So the range is also all real numbers. Our next parent function is a little more complicated, but not by much. It looks pretty similar. It's y equals x, but it has these funny lines on the sides. You remember from Algebra 2 that those lines mean absolute value. So we plug in a value for x, and what we get out is the positive version of that number. So if x is -3, y is the absolute value of -3, which is 3. We can plug in anything we want. You can plug in positive and negative values, so the domain of the absolute value function is all real numbers. But since we can only get out positive values, or 0, the range is all non-negative real numbers. And again, the x-intercept is 0, 0, as is the y-intercept. So you can think of this vertex where these two lines meet as the focal point. And focal points are going to become really important when we start talking about transformations. So important property of this graph is that it's just two lines combined. They make a V. One way that I remember this is absolute value has a V in it, and so the graph is a V. Use that to remember it if you like. Our next type of function is also familiar to you. It's the quadratic function. And the parent function version of this is y equals x squared. So it looks kind of like a linear function, but we've got this power of 2 here, which is what makes it quadratic. You can plug in anything you want for x, so the domain is all real numbers. The range is all non-negative real numbers because, as you know, if you square something, you get something positive. Again, the x and y intercepts are 0, 0, so the vertex of the parabola is at the origin at 0, 0. That's going to be the focal point. And I use the word parabola, of course, if it has a power of 2, it's in the shape of a parabola. So this one you can think of as it's facing up because it's positive x squared. We'll talk a little bit more about graphs of quadratic functions later. And its vertex, the turning point, is at 0, 0. Those are important properties of this graph. So the next function is the square root function. So y equals square root of x. I put these two functions next to each other because how do you undo a squared power? Well, you take the square root. So these functions are related in a way. And if you notice, let me go back to y equals x squared. This one has the nice U shape. The graph of square root of x has sort of a sideways U, but only one part of it. Now, why is that? Well, we can only plug in positive numbers into the square root function. So the domain is all real non-negative numbers, which is why we don't have any part of the graph on the left. The range is also non-negative real numbers because when we take the square root of something, we get something positive. And so the graph is only on top. So we're only in quadrant 1. Again, the x-intercept and y-intercept is 0, 0 because, and this means our focal point here is going to be 0, 0, the point we're going to focus on. Our next parent function is the cubic function. Cubic because the equation is y equals x cubed. When we have a power like this, we can plug in any value we want. The only times we run into trouble in the domain is if we're taking a square root or if we're dividing if we have an x in the denominator. This gives us no problems, so the domain is all real numbers. And also, the range is all real numbers. You can even see that from the graph of this function. We go down toward negative infinity and up toward positive infinity. There's sort of a focal point right here at 0, 0 where it switches along this little curve. It sort of flattens out there, so that's going to be our focal point. It's sort of an easy point to recognize when you see a cubic function. And you'll notice that as we go to the right along the x-axis, the y values increase, but if we go to the left along the x-axis, the y values decrease. So I was watching another teacher present about this, and she said she calls this the disco function, because you sort of have like this as kind of a disco dance move. Now, how do you undo a cube? You take the cube root, so that's our next cubic function. And remember, the 1/3 power is the same as the cube root. Down here you have the cube roots notation, and here we have the rational exponent notation, but they mean the same thing, and it's just the opposite of the cube root of the cube. So if you look at the cube function, we have disco arms. If you look at the cube root function, you have sort of sideways disco arms. When we talk about inverse functions, we'll see exactly why the graphs do this, that they're so related. Again, the power is to the 1/3. It's not to the 1 over an even power, so it's not a square root. So the domain is all real numbers. The range is also all real numbers, which you can notice from the graph. And again, you have this sort of flattening out at 0, 0, so we'll call that the focal point. It also happens to be where the x-intercept and y-intercept is. Now our final parent function might look a little strange to you. It's a brand new one. This is called the reciprocal function. Reciprocal because it's 1 over x, so we're looking at the reciprocal of x. So when we talk about the domain of this function, well, we have an x in the denominator. That gives us a problem. So what value of x is not allowed? Yeah, 0. So the domain is all real numbers except for 0. The range is also all real numbers except for 0, because what value for x could you possibly plug in and get out 0 for y? There is none. You can try anything you want. Try really, really big values. They'll get close to 0, but they will not reach 0. So the domain is all real numbers except 0. The range is also all real numbers except 0. Since we can't plug in 0, there's not going to be a y-intercept. Since we can't get 0 for y, there's not going to be an x-intercept. So this graph has no intercepts. Instead, what we have is called asymptotes. We're going to talk a lot about these later, but this is a great example of asymptotes. An asymptote is just a line that the graph approaches. It gets closer and closer and closer to this line, but it never ever touches it. So if you look at the vertical line, x equals 0, as the x values get really small, the y values get really, really big, but since we can't plug in 0, we're never actually going to touch the y-axis. Similarly, if you look along the x-axis, as the x values get really, really, really big, the y values are squeezing towards 0, but they never actually hit 0. So that's why we say this graph has two asymptotes, x equals 0, the vertical one, and y equals 0, the horizontal one. So now let's do some examples of the kinds of things that I would ask you to do with parent functions. So let me switch my screen. Okay, so here are some examples. The first one is y equals negative 3x squared plus 2. So what is the parent function here? That's what I'm asking. And if you think back to what we just did, well, the closest function that this resembles is the quadratic. It has a power of 2. So the parent function is y equals x squared. We have some extra stuff going on. We've added a 2. We've multiplied the x squared by 3, and we've put a negative in front. So when we talk about transformations, we'll see what each of these additions to the parent function, what they do, how they change the graph. Our next example, y equals the square root of x plus 3. Well, what's the parent function? Think about it for a second. It shouldn't take you long, because the parent function is sitting right here, square root of x. So y equals square root of x is the parent function. Now let's do some graphic examples. What is the parent function of this graph? Here's a hint. It looks kind of like a V. Okay, the parent function is y equals absolute value, V value of x. This isn't the graph of y equals absolute value of x. This is just the parent function. So let me label these. It's parent functions. I'm not giving you the equations for the graph. I'm just telling you what the graph came from, who its mom or dad was. Okay, so what's going on in this one? What's the parent function? Well, this is our focal point. It sort of shifted from here to here. It used to be at the origin, now it's there. But if we imagine this graph through the origin, do you remember? Disco arms, y equals x cubed is the parent function of that one. And finally, we have a line. So which one is it? Line is linear. So the parent function here is just, oops, I don't know what's going on. Okay, there we go, is y equals x. Even though we know y equals x looks more like that, so this has a shallower slope, the blue graph, and it has some intercepts besides 0, 0. So we could come up with what the equation of this line is if we really wanted to, but I'm just asking for the parent function. Okay, great. So get these memorized, do the practice problems, and you'll be all set to go when we start talking about transformations.